has been completely cleaned and all loose paint and dirt have been removed. The first step in disassembly is to remove the end covers which hold the bearings in place. But before removing them, he carefully match marks the end covers and the positions where they mate with the housing. There's an important reason for doing this. The gear reducer is going to be completely disassembled, and those end covers could be accidentally put on the wrong side of the casing when it's reassembled. So to ensure the unit can be reassembled properly, he match marks the covers and the housing. That way he's sure everything will go back in its proper position. So he continues match marking the covers and housing until all covers that will be removed have had either a letter or a number placed on them. By numbering one side and lettering the other, he minimizes the possibility of improper reassembly. In this case, he uses metal dies to do the marking. If he used a paint marker or a felt tip marker, it's possible that the marks could be removed when the unit was cleaned or disassembled. With this method, he's sure that the marks won't accidentally be removed when the unit is taken apart. This marking process continues until all the covers and their positions on the housing have been match marked. With the match marking completed, the next step is to remove the end covers. These covers have to be removed carefully. They have gaskets and shims under them. The shims must be kept with their respective covers so bearing clearances won't be disturbed. In this case, the worker will use paper tags to identify each cover that's removed. He will also use strings to hold the shims and gaskets together with each end cover. To loosen the first cover, the workman uses a crisscross pattern. This assures that any pressure on the flange of the cover is relieved evenly. If he didn't do this, the cover could be distorted as it was loosened. As he loosens each bolt, he also feels for any resistance in the threads, which would indicate that the threads had been damaged sometime in the past. If he found one that was damaged, he would replace it before putting the unit back together. This work may seem fairly simple, but it's very important. In addition to relieving pressure evenly on the flanges of each end cover, it also protects the bearings which are installed underneath each one of these covers. If the pressure isn't relieved evenly, the outer rings of the bearings might be damaged. He continues loosening until all bolts have been removed and placed in a container. Once all the bolts have been removed and placed in their container, the cover is slid off the shaft. Once he's removed the first end cover, he checks the gasket and shims to see if there's been any damage to them while the unit was in service. The gasket is going to be replaced, but he saves it at this point because he can use the old gasket as a pattern for cutting a new one when the unit is reassembled. He has to keep the shims with each end cover. They're used to establish the proper position of the outer ring in the housing. If the shims get mixed up, improper bearing clearances will result, causing premature wear or failure. So he ties the gasket and shims to the end cover with string. Once he's completed tying the gasket and shims to the first end cover, the next thing he does is to identify where this end cover came from. He fills out a tag to clearly identify these parts. This method helps to prevent losses. It also minimizes the possibility of improper assembly because all associated parts are kept together. Once all the parts have been fully identified, they're placed with their end cover and set in a safe location. They'll be inspected later on. Once he's finished removing the first end cover and he's sure that all components for the end cover are with it, he's ready to loosen the next end cover. As before, he loosens the bolts in a crisscross pattern. You'll recall that we said this is to protect the flanges of the cover. It also protects the outer ring of the bearing underneath that cover. So he continues doing this on all covers on the gear reducer until they've all been removed and set aside with the bolts that are used to connect them to the housing. So far we've seen some of the preparation for removing anti-friction journal bearings from a gear reducer. There's still more preparation work to be done. But before we get to that, let's take a break. Before the break, the worker had just finished removing the end covers from the shafts. The upper half of the gear housing needs to be removed before he can remove the bearings. Let's see how he does it. Before he begins to loosen the nuts and bolts which hold the top and bottom halves together, he has to remove 2 alignment pins. This is done by driving them out of the flange with a hammer and punch. The pins are placed in the flange so that the top and bottom half of the casing mate properly with each other. This assures proper alignment of the openings for the outer rings of the bearings. Once the pins have been removed from the flanges at each end of the housing, they're placed in their own bag and set aside for use later on. With the alignment pins out of the way, he's ready to begin loosening the bolts for the upper and lower housing halves. 2 sets of wrenches are needed since the bolts are of different sizes. Again, he loosens the bolts in a crisscross pattern. This protects the flange mating surfaces because it minimizes the possibility of their being distorted as the unit is disassembled. The crisscross pattern also assures that stress is relieved evenly on the outer rings of the bearings. If this weren't done, it's possible that the outer rings of the bearings could be damaged. So this step is very important. You don't want to damage a good part as you're disassembling it. The time spent to do the job properly pays off in the end. So he continues using a crisscross pattern until all the bolts and studs are loosened. Then they're placed in bags and set aside. With all the bolts removed, he's ready to lift the top half of the housing off the bottom half. To do this, he has to do a little preparation work first. He's going to be handling wire rope slings, so he puts on his gloves before actually starting the work of connecting the lifting equipment to the top half. What he's doing here is making a special sling set for lifting the top half of the housing from the bottom half. He attaches one end of the 3 slings together with a shackle. Using that shackle, this end of the sling will be attached to the chain hoist, which will be used to perform the lift. Then the other ends of the slings will be attached to the top half of the housing, again using shackles. You'll notice that lifting lugs are provided on the housing for this purpose. The purpose of all these preparations is to ensure that the top half of the housing is lifted straight up from the bottom half of the housing. That's very important. If the housing shifted as it was being raised, it might hit the bearings or the gears. That could cause severe damage. These may seem like routine procedures, and I suppose they are, but they must be done properly to ensure the bearings and gears aren't damaged as the housing is raised. So the worker and his helper continue connecting the slings and shackles to the lifting lugs on top of the housing until all the slings have been attached. Now, as each connection is made, the workman checks to make sure that the shackle is properly installed. If the shackles weren't attached properly, the upper housing could jerk as it was raised. This could damage the bearings, gears, or the flange mating surfaces of the upper and lower housings. Once all the shackles and slings are connected, the helper takes the strain on the chain hoist. But they don't begin lifting until the entire rig has been checked. The worker wants to be sure the rigging is aligned properly. This way, he's sure the flanges will come apart smoothly. As the cover is lifted off the gear reducer, the worker checks continuously to make sure the top casing doesn't strike any gears or bearings on the inside. And he checks frequently until the top half is clear of the internal parts. Once he's satisfied the top half of the housing is clear of the gears and bearings, the top half is moved out of the way. Once it's out of the way, it's set on timbers and the rigging is disconnected. Okay, you've seen the preparation work for getting to the bearings. At this point, the worker is ready to take the bearings out of the gear reducer. But before he does that, let's take a break so that you can review this preparation with your instructor. When you come back, we'll see how the bearings are taken off the shafts and inspected. Before the break, the worker had just finished doing the preparation work for getting to the bearings in the gear reducer. He had taken off the top half of the housing and set it aside. In the meantime, the gaskets have been removed and saved to be used for patterns to cut a new set of gaskets. Before beginning the next step in the disassembly process, he's careful to clean his hands. This is an important step because any dirt or grease on his hands might accidentally get on a bearing surface. That could damage the bearing. This is particularly important with anti-friction bearings. They're built to extremely close tolerances. Once he's satisfied his hands are clean, the first shaft with its bearings is removed from the gear reducer. As he does this, the worker protects the bearings by working smoothly. A sudden jar could scratch a bearing surface. Once the shaft has been removed, it's placed on a set of wooden blocks to support it during disassembly. The outer rings are removed from the bearings. You'll notice here that what we're working with are two roller bearings. These particular roller bearings have removable outer rings. This is somewhat similar to the arrangement you might find on the front wheel bearings of your car. The worker performs an initial cleaning and visual inspection of the first outer ring to see if there's any obvious damage. Before he does a thorough inspection, the parts are going to be completely cleaned. This is just a quick check to look for any gross damage that may have occurred when the gear reducer failed. This type of check can tell you a lot about the condition of a bearing. It can also help you find the cause of an equipment failure. Seized bearings, or bearings that have been overheated, can be found this way. Seized bearings would be locked or frozen in position, so the rollers wouldn't move. Bearings which have been overheated would have a blue discoloration on the rings. In this case, the bearing isn't seized and there is no blue discoloration on the outer ring. So he places the ring in a plastic bag. Once the ring has been placed in its bag, he makes out a tag noting the location it came from. This is most important because at this point, he's not sure of the ring's condition. So he's going to assume it's in good shape and treat it that way. If a detailed inspection shows the ring's okay, he'll need to return it to its original location. Once bearings have been operated, the rolling elements should be used with their original rings because they'll have compatible wear patterns. Once the worker finishes checking and tagging the first outer ring, he turns his attention to the second outer ring, and he repeats the same cleaning and inspecting steps that we just saw. He performs an initial cleaning with a lint-free cloth. This uncovers any obvious defects, such as evidence of overheating. He carefully inspects the inner portion of the ring, or the track where the rollers meet the ring. Because if the bearing is badly worn, it'll show up here. You'll notice that while he's doing this, he's very careful not to touch any surfaces where the bearing action actually takes place. In other words, he's careful not to touch the inner portion of the ring with his fingers. Perspiration or oil from his fingers could possibly cause pitting of the ring. That could result in a bearing failure. So by not touching the exposed bearing surface with his hands, he can reduce the possibility of bearing failure. Again, once he's inspected the ring, he places it in a plastic bag and fills out a tag noting the location that the ring came from. As you recall, we said that this is so the unit can be assembled in the same configuration. And once he's filled out the tag, it goes in the bag with the ring. Then the bag is sealed, closed, and set aside. It'll receive more attention later on. With that, the outer rings have been removed, inspected, and safely stored. The inner rings could be removed from the shaft at this point, but it's going to be a while before he gets to that job. So in the meantime, he's going to cover them up. The reason for this is to prevent dust or grit from getting into the bearings. We do all of our bearing work in a clean shop, and we keep the workbench as clean as possible. The worker also makes sure that they keep their hands as clean as possible. But there are times when grit could get on bearing parts, so we make sure that bearings are covered with clean, lint-free cloths when we're not actually handling them. For the same reasons, the gear reducer is covered with a piece of plastic at this point. This prevents any dirt or grit from falling in on the exposed gears or falling in and contaminating the other bearings. Each one of these shafts, along with its gears and bearings, will be thoroughly inspected in the process of overhauling the gear reducer. But since it'll be a while until he gets to the next shaft, the workman covers the unit. As we said, what this does is prevent the gears or the bearings from getting contaminated. So he tapes the plastic cover in place until he's satisfied that it will remain in position and prevent any grit from contaminating the inside of the gear reducer. Your plant may use slightly different procedures for covering open equipment when it's in a shop. For instance, wooden covers are sometimes used. If wooden covers are used, they not only protect the inside from dirt or grit falling in, but they also prevent mechanical damage. The next thing we need to discuss is the removal of the inner rings of the bearings from the shaft. But as I said, it'll be a while before our workman gets to that. So let's take a break and let you review the initial disassembly and inspection of bearings with your instructor. When you come back, we'll see how the inner rings are removed. Well, we said the next step to be discussed was the removal of the bearing's inner rings from the shaft. Our workman is preparing to do that right now, so let's watch. Before starting any work which might involve touching the bearings, the worker is very careful to clean his hands. You'll recall we said this is done so he doesn't accidentally contaminate a bearing. I've been emphasizing the use of clean, lint-free cloths. It's very important that any covers or materials used to handle bearings are free of lint. Lint can get into a bearing and destroy the bearing surface. So if you're going to cover a bearing, be sure that the material you use is lint-free. Once the covers are out of the way, he then cleans the gear teeth. They're going to be covered with tape, so he wants to be sure that the tape will stick to the teeth. The reason the teeth need to be covered is that the shaft is going to be placed in a press. If the shaft accidentally shifts, he wants to be sure those teeth are protected. If they're damaged, the shaft could be ruined to the extent that it couldn't be reused, or it might need a lot of rework. So taking time to cover the gear teeth is time well spent. It could prevent equipment damage. In our case, we use a plastic tape to do the work. This method is used because it does a good job of protecting the teeth. But of course, before the worker places the shaft back into the gear reducer, there's one important step that must be done. The gear teeth will have to be wiped with solvent to remove any adhesive left by the tape when it's removed. Once he's applied several layers of tape to the gear teeth, he's ready to set up the press. To begin with, he has to know the distance from each bearing to the end of the shaft so that he can set up the press properly. To find this distance, he uses a folding rule. You'll notice he's very careful not to touch the rollers. Even the surface of that rule could put a scratch on one of those rollers. If the rollers were damaged, a bearing failure could result. So at every step along the way, he's very careful to protect the bearings. Remember, we said earlier that bearings are very precise pieces of equipment, and they're built to very close tolerances. So every effort must be taken to protect the bearing parts from damage or contamination while working on them. After taking his measurements, he replaces the covers on each bearing. Then, he's ready to set up the press. What he's doing here is using the measurements he just took on the ends of the shaft to set up the press. To position the cross brace properly, he first removes a pin from each end of the cross brace. Then the cross brace is moved until it's in the correct position to remove the bearings. This cross brace has two sets of pins. One set fits below the cross brace and supports it. Then there's a second set of pins that's placed in the frame of the press to hold the cross brace in position. Both sets of pins have to be properly positioned before he begins any bearing removal work with the press. Once the pins are in position, he places the V-blocks on the cross brace and checks to make sure all tension has been relieved on the raising cables. If the cables were allowed to remain under tension, they could be broken when force was placed against the cross brace. Measures the distance from the cross brace to the ram to verify that the press is properly set up to do the bearing removal. But before beginning the removal work, the worker puts on his safety goggles and gloves. The reason for this is that the bearing could possibly shatter as it's being pressed off the shaft. Wearing his safety equipment ensures that if there is an accidental breakage of the bearing during the removal process, he's not as likely to be injured. At this point, the press has been set up, the worker is wearing the necessary safety equipment, and he's ready to remove the first bearing inner ring from the shaft. So he has his helper place the shaft in the proper position in the press. While doing this, he's very careful not to strike the bearing on the cross brace. That could ruin the bearing. This is one case where slow, careful work saves time and money. The next step is to properly position the V-blocks underneath the bearing. The blocks have to fit underneath the inner ring, but they can't touch the cage. At this point, he brings the second block under the inner ring. Both of these blocks have been measured beforehand so that they'll position the shaft at right angles to the cross brace and fit underneath the inner ring. That way, all force is applied evenly. If one block was higher than the other, the shaft could shift when the press was activated. Before beginning the pressing operation, he takes one more important step. He places a brass spacer between the ram and the shaft. This is done to ensure that the end of the shaft is protected, because if the shaft was allowed to come in contact directly with the ram, it's possible that the end of the shaft could be flared. The brass just prevents the flaring action from taking place. Then, to make the removal as smooth as possible, he places a light coating of oil on the shaft itself. This prevents the bearing from binding as the shaft is pushed out. Once everything's in position and his helper is holding the shaft so that it won't drop out when the bearing comes loose, he begins pressing the shaft out of the bearing. Now, this may take a while. If you reach a point where the shaft binds, the hydraulic pressure will get too high. If that happens, stop and find the cause of the problem. Don't try to force the bearing off the shaft. In this case, the worker doesn't note any binding, so he continues pressing on the shaft until the bearing and shaft are separated. At this point, the shaft has to be watched closely. If it drops, the bearing on the other end or the shaft itself could be ruined. As you can see, the two workmen are working very slowly and carefully so as not to damage the shaft. Now, once the bearing has been removed, it's placed in a bag with its outer ring. Then the removal process is repeated on the other bearing. At this point, we've seen the procedures for removing anti-friction bearings from a shaft. In a few moments, the worker will be ready to inspect the bearings. But before we get to that inspection work, let's take a break. Well, before the break, the worker had just removed the bearings from the shaft, and he was about ready to clean the bearings and inspect them. Let's rejoin him and see how that's done. Before beginning any cleaning, the worker has placed 2 containers of solvent on the table along with 1 container of clean lubricant.